Welcome back, ladies and gentlemen. In this video, we're going to be looking at some of the fundamentals of constant motion. So why would we want to study this? Well, what we're essentially doing is tracking where and when an object's position at various times. As time goes on, the position will be changing. This is the beginning step in analyzing more complicated motion, and from there into more complicated topics as well. And so we really need to nail this down. Now, it's really not that complicated, you'll see. In order to do this, we're going to have to deal with something called a coordinate system. And essentially, when we assign a coordinate system to a situation, we're simply saying which direction in that situation is positive. It's very important to identify that. You'll see as we go along. So we're going to look at an object, and we're going to track its position every second, let's say. And in this situation, we're going to say our coordinate system indicates that to the right will be positive. We can decide any direction we want, but let's just call it to the right. And we've got Mrs. Kangaroo with Junior hanging out, and we're going to say that, well, Mrs. Kangaroo will be here at that dot, and we're going to start tracking her position at various times. So 1 second later, because we're tracking each second, she'll be here, 2 meters further to the right. And then 1 second later, 2 more meters to the right. 1 second later, 2 more meters to the right. And 1 second later, 2 more meters to the right. And so that is the motion that she is exhibiting. And so we can kind of just record the time and record the position, time in seconds and position in meters. Now let's look at what we have. We can talk about the speed. Now, speed is the distance traveled divided by the time. So how far did Mrs. Kangaroo travel? Well, she traveled a distance of, well, that's 2, 4, 6, 8, 8 meters. And it took 4 seconds to do that. So Mrs. Kangaroo's speed would be 2 meters per second. It's important to understand, because we're dealing with constant motion, that the same distance in equal amounts of time means the constant speed. The speed is constant, unchanging. And we can clearly see that the dots are equally spaced apart. And so we can say, well, it took, in that 1 second she traveled 2 meters. That's 2 meters in that second. There's 2 meters in that second. So 2 meters per second, and the speed is constant. Okay. Now there's a new concept that you may have heard of, but most people aren't very familiar with it and don't quite understand it well enough. Velocity. Now, velocity is equal to displacement divided by time. Displacement is a different word than distance, and it has a different meaning. Displacement actually means the change in position, not just how far, but the change in position, and that's really important. It's a subtle difference. So we're going to specifically deal with the average velocity. That's technically what we have to call it, but we don't always have to say the word average. So average velocity is going to be displacement divided by time. Displacement is change in position. This triangle is called a delta symbol, and anytime we see that, it indicates a change in something. So we see a change in position divided by a change in time. It's kind of a formal way of writing it, but x is just, well, what is the position? I'll say along an x-axis, for example. It's just a distance kind of thing, but it's more than distance, it's displacement. You'll see that in a moment. So the triangle, we say delta. We can say delta x divided by delta t, or change in position divided by change in time. And it just means change in. Now, in order to figure that out, well, we could also say final value minus initial value. And here's what that would look like. Average velocity will be equal to, well, it's displacement divided by time. So change in position divided by change in time. And to figure out the change, final position minus initial position divided by final time minus initial time. Okay. So the final position is 8 meters. That's where Mrs. Kangaroo ended up. And the initial position was 0. And it's measured in meters. The final time was 4 seconds, and the initial time we started watching at 0 seconds. Okay, so that becomes 8 divided by 4, 2 meters per second. And that looks the same as the speed, and that is actually true in this example. But now let's look at what makes velocity different from speed. So if the direction is reversed, so for example, if Mrs. Kangaroo is going to go the opposite direction, she's going to start here at a time of 0, but that position is a position of 8 meters. And then 4 seconds later, 1, 2, 3, 4, she's going to end up here, and that position is 0 meters. And so this is interesting to note. We cannot change the coordinate system. That will be consistent. But now, if to the right is positive, she is going in the negative direction. And we're going to see that. Let's look at this. So average velocity when she's going in the negative direction. We have final position minus initial position divided by final time minus initial time. The equation is the same. That doesn't change. But look at this. Final position is 0 and the initial position was 8. And the time doesn't change. Final time is 4 and initial time is 0. So this becomes negative 8 divided by 4, and the answer is negative 2 meters per second. This is different. And now if we were to look at how fast Mrs. Kangaroo was going, her speed, well, she still went the same distance, 8 meters, in the same time, 4 seconds. Her speed would be the same, 2 meters per second, but her velocity is negative 2 meters per second. So here's what this means. We see the minus sign in front of the answer, and that simply tells us direction. It tells us that according to this coordinate system that we have assigned, that she is traveling in the negative direction, not the positive direction. So a velocity of negative 2 meters per second is different than a velocity of positive 2 meters per second. And when she's going one direction versus the other, that means she has a different velocity. But that doesn't mean she has a different speed. So velocity is kind of like speed with direction, but I'd rather you just memorize and remember the distinction here. Speed is distance divided by time. Velocity is displacement divided by time. And the word displacement has a very specific meaning, change in position. That's it for now. Thank you for watching. I'll catch you next time.